Dr. Rajan Rajendran got his PhD from Iowa State University in the United States. He holds a degree in mechanical engineering, and he has had a long career with Emerson Climate Technology, and he's currently the Vice President of Systems Innovation and Sustainability, with experience in the field for over 25 years. He serves in many committees. I have the pleasure to serve with him in the UNEP RTOC committee, and he also serves in many committees in the industry. Dr. Rajan, please come in.
Good afternoon, and I want to thank all the organizers of this conference for inviting Emerson and inviting myself to speak. And you can see that I was forewarned from the previous speaker, so I've come prepared with my own bottle of water. I don't smoke, but I still expect to choke up here. Anyway, I think you've probably heard a lot about the various safety measures and things like that you have to follow when you start using low GWP fluids. The reason for that is very obvious. It's not that you do not need to follow safety guidelines with current HFCs or HCFCs. You have to follow certain safety procedures. Every technician is trained. All the processes are there. The documentation is available from the compressor manufacturer, from the equipment manufacturer, and we all know what to do. That is the big problem. We know what to do with today's equipment. All of these new low GWP fluids, whether it is CO2 or propane or some of these A2L blends, they are new to us. They are new to us in some of these applications that we are putting them into. And therefore, we have to retrain ourselves. The previous speaker spoke about training and certification. But retraining is important because today's technician who's got 30 years of experience cannot do the same thing with propane that he used to do with R22. So you have to go through the retraining process. So those are some of the things to be noted. And from an Emerson point of view, that's strange, I'm too short to see over this. All the little problems that we have. On the left side of your chart, you see that there is a holistic way. This is a chart that I have shown numerous times. Others have shared similar material as well. And you can see that safety is right on top. Of course, you want performance, you want economics, you want to support the environment and protect it. But safety handling is extremely important. And when you look at the low GWP fluids, I've got CO2 and propane and all the low GWP candidates listed there. Those are the ones that I'm going to specifically talk about. And I know that CO2 is in refrigeration, but in the Middle East, there has been talk about using CO2, whether it is in the transcritical or the cascade system in supermarket refrigeration, and I thought I would add this in because I don't know that many speakers would have talked to you about CO2. And everything that I have here in this presentation, there's documentation, and I've given you the references, so you can feel free to go to all these references and get a whole lot more material than what I'm going to share with you today. What are the issues? So when you talk about CO2, pressure becomes your number one issue. Much, much, much higher pressure. Toxicity. If you have very high concentrations of CO2, then it can become toxic. So you got to worry about that. You got to be aware of the high pressures and how to handle that. And third thing, which is not talked about a whole lot, is the potential for dry ice formation. When CO2 leaks, it can form dry ice, and that can lead to some issues as well of plugging and so on. So one has to be aware of that. When you start talking about propane, without question, flammability is number one item that everyone talks about. And of course, it is charge restricted in most applications. You've got to be aware of that and require special handling. And we'll look into some of those things. And finally, the A2L blends are also flammable. They're mildly flammable, but they're flammable nevertheless. So those are the three things that one needs to be aware of. So let me just walk fairly quickly through CO2 because I know that that is probably not of a whole lot of interest to everybody here, but I will point out some of these things. CO2 is odorless and colorless gas, and it has a certain limit, and all these limits and numbers are all right there. And in many of these installations, especially supermarket, if you're going to put all the CO2 in a machine room, you have to be aware of that, and you have to make sure that you have adequate sensing technology so that when the CO2 levels do go up in the machine room, you have a way to warn you and to take some action like ventilation and so on. As I said earlier, CO2 is a high pressure gas, and because it's high pressure, in fact, you can see some of the numbers there. For every 1 Kelvin, 1 degree C, if you will, the increase in pressure for CO2 is 10 bars. So it's just a whole lot more than what you're used to with all the standard refrigerants. Again, all of these things can be done through training, and if you look at some of the equipment, they'll all have pressure relief valves, and in the case of CO2, many of these systems will even have auxiliary units to try and keep the pressure down, because what happens with CO2 is when the ambient temperature, when the CO2 system is shut down, the pressure can get pretty high, and then all the gas will have to be ventilated out. Dry ice formation, because of the triple point of CO2 being what it is, about 4 bar and minus 56 Celsius, much higher than the atmospheric pressure, when you release CO2, there's a potential for dry ice formation, and therefore all the precautions have to be taken. I think somebody else mentioned something similar to this as well. Again, as with all these gases, whether it is CO2 or propane or any of the A2L fluids, venting them outside is important. You just cannot vent them inside occupied space or inside closed quarters. This is going to be a repeat. Only trained and qualified technicians should be allowed to operate on any of this equipment. Good vacuum, I think a gentleman that spoke earlier was talking about pulling a good vacuum. That's essential, because anytime you have moisture and you have any contaminant in the system, whether it is CO2 or propane or any other refrigerant, those can lead to problems, significantly more than some of the other fluids that we're used to. Propane. Enough has been said about that, but let me point out a couple of things here. There are lots and lots of standards out there. There are lots and lots of labeling that you'll see. But if you don't know what the standards are saying, and if you don't know what these labels mean, that is not going to help you. And therefore, again, it is extremely important to stress the fact that you have to train everybody in how to handle propane equipment. It has very similar characteristics. The temptation to use R22 equipment for propane can be very high. If you don't have a compressor and a compressor fails on a propane unit, people may be tempted to just go get an R22 compressor and put it in there. But those kinds of things should not be done. You have to use equipment and components specifically designed for propane. That's important, because there's lots of things that go into the design of these components, and one shouldn't assume that just because it looks and acts like R22, it must behave like R22. Filter dryers are important, and you can see some of those other things about labeling and so on. Evacuation and charging was also discussed. The process of servicing any equipment is probably the most riskiest part in this equipment's life. It's easy to, the manufacturer has a very controlled environment. The equipment is shipped, it's installed. The installation and service is most important. When something goes wrong, when somebody comes to fix it, they have to know what to do. And if they're charging, make sure that they know what the charge limits are. You cannot charge more refrigerant to propane. You could do that with an R22 equipment. You can charge more than you really need, and the equipment won't work well, but you cannot do that with propane. So charging to proper levels is extremely critical. Again, who does that? The service person. So that's why, again, I come back to the same point about service technician. Leak testing, whether it is CO2 or propane or any of the refrigerants, leak testing is always important. But how you do your leak testing has to be done very carefully. Use the proper equipment, do not take shortcuts. These are all some of the things that we have published in our own documentation. Somebody mentioned that you have to have specific equipment for each of these refrigerants. That is going to be an issue in our industry. At one point in time, it was sufficient for a technician to carry just one piece of equipment, one tank of refrigerant. But I think those days are long gone. They're going to have multiple tanks of refrigerant, multiple leak detectors, and they need to know what to use for what. A2L low GWP fluids, there's going to be a couple of other speakers here who are going to come and talk more about this. So I will have very little on this other than to say the ISO 5149 is the first and complete standard to be released for A2L fluids. There are other standards that are coming. Much of what this is about is to limit charge and to tell you how to install it. So the installation procedures are all very detailed. One has to follow those instructions because those charge limits have been determined based on the installation procedure. So if it's installed incorrectly, the physics of what happens when a leak occurs is completely different. So following instructions is important. I'm going to skip over this chart because this is the status of different standards, and you can see that later. There was some discussion about risk assessment. There have been a lot of studies done, and there are more studies that are being done on risk assessment of all these different fluids. I would recommend that you get all those documents and see what you can learn from them. But one thing you'll see is every one of them will always talk about training the personnel and following the procedure, training the personnel following the procedure. One study even recommends that with a properly trained service personnel, the risk of any safety issue is decreased by a factor of 20. So those are all important things to keep in mind. Finally, I don't know whether I've reached my limit or not, but I will use this to, oh, I got 5 minutes more, okay. Okay, so the new lower GWP refrigerants in air conditioning and refrigeration, everything that we are going to see as Europe begins its phase down path and the United States talks about moving away from some of the high GWP HFCs to lower GWP fluids, we are moving into an arena, we're moving into an area of higher pressure gases and flammable gases. I don't think there is any question that we're going to avoid that. So now the question is, how are you going to mitigate some of those risks? And the way you mitigate them is to make sure that you give yourself adequate time for the transition, okay? It cannot be done overnight. If you decide that tomorrow you want to go to propane, it is not as simple as flipping a switch. There's got to be a lot of work done in preparing for that. And that last bullet that I have there, that's exactly what I'm trying to say. Successful transitions to lower GWP state can only be achieved if all the steps in the transition are carefully planned and executed, especially the one relating to safe use. What you don't want to do is choose to go to some fluid and then find out within a year that you made a mistake because your infrastructure is not set up for that. It's not only your manufacturing. There was some talk about manufacturing lines being ready, which is great, but transportation is important. You heard how important transportation is important. Transportation is important. But then there is also the safe storage of your equipment. Do people know how to store equipment that is being charged with propane or A2L fluids? That has to be carefully thought out. And then the sale, the installation, and definitely the service, because everything you sell is going to get service over the course of the next 10 to 15 to 20 years. And all of this, again, comes back to training, and certification. So I cannot emphasize that enough. I cannot emphasize the need for a careful path. That is the reason why I was talking to Andrea Voigt earlier. That's the reason why the phase down, stepping down helps, because it gives you the time to move from one to another and get used to doing something and get your infrastructure all readied up. So with that, I'm going to conclude my talk, and if you have any questions, I'll be happy to answer them at the very end. Thank you.
Thank you very much, Rajan, and compliment to the speakers. So far, we are perfectly on time. I would like to introduce now Bernhard Siegele, and again, I'm lucky because I can save some more time. You all know him by now because he presented already. So with this, I'm going to hand over immediately. He's going to tell us about working hydrocarbons in RAC equipment handled with care and competence. Bernhard.
Thanks very much. Yes, so well, if GIZ is known, I think it's mainly for one thing, and that is capacity development, capacity building. And the speakers before me already placed many of the issues that I can skip or just do on a superficial basis, because I think we all more or less agree. So I skip this one as well, since I've said that before. What I want to show here that well, natural refrigerants, our credo and what we really believe as a sustainable option, is suitable in the various forms for all different temperature zones. Of course, always given that it's applied with care and competence. And this is what we see already on the world market. We see about 700 million fridges for domestic use. We see millions of ice cream freezers and bottle coolers and so on. I said before about 100,000 split AC units, so also in larger... Oh, sorry, you can't hear me despite the... Sorry for that. So hydrocarbons are also being implemented and applied for larger chillers, of course with suitable design and safety measures, and also in industrial applications. So there are more and more applications where hydrocarbons are being put on the market. And the very important thing in that is the systematic approach, that it's done with care, it's done with planning, strategy. And there are several elements, of course, that we consider important. One is that innovative technologies are accompanied with know-how, and that the demonstration is applicable, it's proven. It goes along with awareness, education and skills, again on a strategic and planned way. And on the other hand, we need supporting measures such as normative action, which would be certification, registration, regulations and standards, quality assurance, and also monitoring and enforced control. And both these elements or groups of elements lead or need to lead to a behavioral change. We heard that technicians are not familiar with new refrigerants, with new alternatives, and therefore we need to build these competencies in various ways. And we see that along the equipment stages, from product development down to the disposal of the management, the different personnel involved, from the R&D engineers and decision makers to the service technicians, and also an example of activities that are added along the way. And that does not just concern the technicians in the field, but a lot more education is necessary also for the development engineers, because it's simply not sufficient just to know what they are doing, which would be an informal technician. It's not enough to know how they are doing it, which is usually formal education, but we want to get them there that they know why they are doing things. So we have competent persons in the field, competent persons in the enterprises that help to realize this transition. And that involves all the stakeholders on a national basis, from industry associations down to research institutions and others. And we also believe that getting the different types of equipment into the market and being ready for the market to be used in a safe way and competent way also depends very much on the complexity of the issue at hand. And in that respect, we have developed this kind of overview table where simple equipment such as refrigerators would need about 1 year, we would say, of preparation and development to get it ready for the market, while more complex equipment would take more and longer. I think these general safety rules are being talked about a lot. I skip it. And applying these rules, we usually go with this decision trees on the different, from the installation, service and maintenance, service in case of accidents and repair works, and also dismantling. The red fields indicating that there are potential leak, potential availability of flammable substances, in our case with hydrocarbons, and these fields need to be taken with care, with special care, which we train our technicians. We heard that it's during installation and leak reduction. I don't think I need to get in details also here. Being competent in bracing in joints that are not leaking is one of the basic requirements. And I think we wouldn't be in this position, in these discussions all along again, if the industry would have done their job properly at the beginning and create tight systems. We wouldn't have global warming, we would have global warming, but not from HFCs, and we wouldn't have the ozone layer problem. So a tight system is, of course, the number one system. We also talked a lot about repair and servicing. I also think I can skip this. You'll get the presentation, of course, and it's all in there. And there's no such thing as a leak detector. That's just one remark. So it's still the technician, it's still the person at hand that will discover a leak. And equipment such as a gas detector would help, but it still needs the competent person to figure it out. And very rarely a leak is that easy to find as in this picture. So with using hydrocarbons, there are potential hazardous situations because hydrocarbons are heavier than air. We also heard about that the concentration might not be directly in the working area, but somewhere far. So the working area must be ventilated and, used properly or maintained properly. We heard about cylinder storage, would not go into details also here. Also the safe working area with no smoking, but I think meanwhile technicians are familiar with that in many cases. A proper workshop area and environment to realize. And all these we have described and elaborated comprehensively in the publications that we have done over the last 20 years in many national programs. And it's all being found, and we are happy to provide and also to instruct and to guide, to coach on these issues. So we believe that the theoretical background is elaborated and prepared for the everyday use in many different applications. What we have done and developed additionally is a training program, an international training program called Cool Training. And that has been started with a vocational training center in Germany, where the target group is trainers from all our partner countries. We are building on this and building up cooperation also with UNEP and UNIDO on this, and with the aim to provide competent training and comprehensive training for trainers with coaching from a vocational training institute in Germany. It's 70% practical work, 30% theoretical background in order to give or to realize what is really needed in the field. The training will be offered 3 times a year in Germany, and additionally we plan regional trainings for trainers and also training with particular partner institutes. All this is part of the Green Cooling Initiative, a program financed also by the German government on promoting green cooling technologies. So transforming to a knowledge-based economy is what we really are after. We are not providing just a training then leave again, but our aim is to put this in a transformative learning process in order to leave competent people behind. Of course, they need additional trainings, but this is exactly what we are doing. And even when we have also heard that such decisions as using R290 is not done overnight. This is a long process, and for this the infrastructure needs to be prepared, and this is exactly what we are supporting our partner countries in order to make sure that products coming to the markets are safe to be used. And well, I think this is basically what I wanted to say. As you've seen, there is a lot more of information in the presentation that everybody will get. But I think the key message is that the learning process is happening. There are thousands of technicians out there and trainers that are familiar with new products, with new refrigerants that can be used. And these are ready to support and help. And so are we. Thank you very much.
Thank you very much, Mr. Siegele. Our last but not least presentation is from Mr. Osami Kataoka-san. Mr. Kataoka is a former senior manager of international affairs at JIRAIA, the Japanese Refrigeration and Air Conditioning Industry Association. He's been doing this role with JIRAIA for a good 7 years or so, since 2007. And he was responsible as a senior manager in JIRAIA to deal with the European environmental regulations mainly. He's been working on several standards such as ISO 5149, 814, and IEC 60335 to 40, and he is focusing basically on refrigerant safety for the last 15 years. He returned back now to Daikin Industry in Japan, and it gave us great pleasure to invite him to come and give his presentation. Thank you.
Thank you very much. Kind introduction. Good afternoon, ladies and gentlemen. My name is Osami Kataoka, and I'm dealing with many safety standards. And today I'm talking about the service procedures with A12 refrigerant. So disclaimer is the same as the one already shown from Mr. Mikoshi, and contents are like this. So the mainly a risk assessment will be introduced, and the result of this risk assessment and some experimental results will be introduced. So the JRAIA is an industry association and about 120 members, and about we are selling in Japan the 8 million of the products, residential product, and about close to 1 million of the commercial size products. And JRAIA is responsible for not only Japan, but also we are doing business globally. So we are considering the climate change, and in Japan, we are not so dare to use hydrocarbon, and most of the company decided to use A12 refrigerants. And the risk assessment study is ongoing, and results are disclosed in the JSRAE. This is the academia website. And if you reach this website, then you can find quite a huge amount of information. Today, we only have 15 minutes, so it is impossible to introduce everything here, but very major part I would like to introduce. And in addition, in next month, we have a symposium in Kobe, and in there, the major result of these risk assessments will be presented. So if you are interested in, then please visit at least this website, or if you can come to Kobe, then the English simultaneous interpretation is there, so you can understand what is talked. Anyway, in Japan, they also already asked the several million of the residential mini splits are already sold, and some commercial size units are already in the market. And this is the one of the major point of the risk assessment. So if you see even the hydrocarbon, the risk is not so extremely high, but if you consider the number of the installation in Japan, about 120 millions of units are setting, then if you sum up these risks, then probably the 1 ppm level of the risk is there, then we will have the 120 fire in a year, and that is not acceptable for us. Some country may be, but not for us. So if you have to use lower flammable substance, and still if you see these values, then the service part or installation or the service or disposal or the outdoor unit has a relatively higher risk compared to the indoor. So if you only consider indoor part, then the risk is not so high, but service must be considered. Then this is the statistics